Hello.
Hello. Hi, Daniel. Yes.
Yeah, so sorry. I lost track of time.
Right.
You know? Okay. I'm so sorry. This won't happen again.
Right.
Joining on my phone.
Okay.
Okay.
Try to fit everything in 1 hour as much as we can.
Okay.
Okay. We were always discussing the three questions as the type thing. So it's a quick feedback for you first. It will always be challenging to you until a certain point to do, major big questions like this. Right? So my question is, you've experienced this a few times. Does it feel unsuitable for you in any way? This is an important feedback. So next year we can change if we need to.
Experience what? Sorry, I didn't catch that.
So I help you understand the lecture note for the important points, right?
Yeah.
Then we jump immediately into your revision package and the exam questions, right? As you can tell, the jump is quite high, right? Because it jump directly to questions that assume you know everything. Obviously, we're still learning, so there'll always be difficulty. We've been doing this for a few times, right?
Yeah.
Is there anything bad about that from your point of view? So that
it's a lot harder to do it on my own.
Of course.
When I'm at home.
Yeah.
Like, I find myself leaving quite a lot of blanks sometimes.
Right. Definitely. You will feel a very big gap. Correct.
Yeah.
Mm. So you're saying that intuition, that is fine, but dealing with it as a homework, that's a little, that's always challenging. Correct?
I mean, it's always going to be challenging. So yeah, I think it's fine. Man.
All right. Now, this is, I'll rank this as the top 2 most difficult topic to understand properly. Right? Yeah. So there's that. So what does that mean? If it works for this topic, if it ever works, like if it works for you, then it'll probably work for any other topic in physics, right? I'm not sure whether this is good news for you, but it seems to be a good news for me. This topic cannot run one and cannot simply memorize one also. So Die must understand there is no other way. There are topics that you can memorize one in physics. I'll tell you if you want to know. This is not one of them, right? And you cannot run because the mark is a lot, like really a lot. Of course, you can memorize to some extent, but you will always feel yourself, inadequate if you memorize. That's definitely true for this topic. Right? Okay. So let's see whether the method works, and the proof is probably in some sort of small exams. So that goes my next question. I don't hope the exam is at prelim on some major exam. Do you guys have small exams in between maybe?
Yeah, there's one as soon as school starts.
So when you say that, I keep forgetting. So remind me, does it include this topic or not? Cannot be, right? Cannot be.
I'm not sure actually. I think they'll give it to us like a week before the test. Like they'll give it to us they'll give us the things that
the syllabus, right.
Yeah, so, as soon as school starts.
So that's why you never ask me how to prepare for the exam. They don't even tell you, right?
Yeah, I just know there's going to be one test at the start.
Understand. So very unlikely that you'll be this topic, right? Very unlikely.
Yeah.
So there's some practical concerns here, right? We keep plowing through this topic, you'll understand it sooner or later. You seem to be that kind of guy, at least if reality doesn't get in the way as in life, right? But the exam I don't think will include this. There is no point. There is no point. There's no way to adequately explain even the gravitational field in 1 week, right? So I don't think that's my prediction. So 2 questions. First one is, don't you want to discuss the past topics in expectation of the exam? That's the first question. Now, what do you think? Don't you want that?
I think that would be wise, yeah.
All right. Then the second question is not so important. If the first question is yes, the second question is simply, when do you think this topic, the gravitational field and electric field, will be tested? If you have some idea, not gonna be the exam, not gonna be the upcoming exam.
I think they'll still try to teach it next year.
Wow. Probably.
Yeah.
So do you think it'll probably be at the term kind of exam, like maybe early March?
Possibly, yeah. I'd say closer to April or May.
So you're saying that there is probably no exam at March. It will be on April or May, usually early May.
That one I'm not sure.
Right, understand.
I couldn't tell you. I'm not a very reliable source. I don't have much information. Right. I'm just going off what I've heard.
Understand.
I know for sure that the first month at least there will be a test, a term test.
Right.
Just see where we are.
Right. Understand. Okay. So before we continue, I'll give you my suggestion. Did you hear my son crying just now? It's quite loud.
Yeah.
Okay. Is it disruptive?
No, really.
How does it sound to you? I'm curious.
Sounds like a kid crying.
Oh, no, as in how disturbing.
Not very. It's just background noise.
Zoom is quite good. That's the Zoom doing the work. Okay. You tell me when there are noises that disturb you. You must tell me, okay? Right.
Okay, sure.
Okay, sure. Now back to our considerations, right? So you are probably 50% into understanding gravitational field and electric field. If you stop doing them right now, you'll pick up soon anyway. So I don't see much of a problem by leaving them for a while. I don't see much of a loss, right? So since you say it's wise to prepare for the exam, we have to make some guesses here. We have to guess the topic they're going to test, because I think 1 week of preparation is probably not going to cut it anyway, right? If you just wait until they tell you what topic. So you must make some guesses. What do you think? Does that make sense?
Yeah.
Okay. Then my suggestion is to open your revision package. So you're going to forget the questions that does not come from the revision package, right? The revision package should contain some sort of trace of what they want to test you, right? Right. So let's go to your revision package. I want to see at least the table of content or something.
Where is it?
I have no idea. You have a revision package, right? You do have, right? Because I thought you're using your revision package for the gravitational field practice for a while.
No, that was just notes from last year.
Oh, you don't have a revision package from your school. You don't have it.
It's like notes lah.
Oh, goodness me.
Just print it out. Wait, let me just give Teams a check. See if he's posted anything.
Right. Just check that first. Right?
Just 1 sec.
If not, we're just shooting in the dark. Wow.
Yeah, no messages since last year. Since the holidays.
Then one practical question. I asked this before, I believe. So just remind it. So some IB, right? You're in IB, right? IB. Some IB school do this lah. Okay, guys, we're gonna discuss the SL syllabus first, so all of them, and then the HL one they'll start discussing end of this year or next year lah, something like. So they make a very clear separation, right? Is that what's happening in your class?
No.
So all you know is that you're all HL people doing HL stuff without any clear separation with the SL people.
Yeah.
Okay. Okay, then you're gonna make some guesses, right? Meaning to say we're gonna practice maybe at most 2 topics from this year. The topics that you want to be better before exam starts. Right now you have some time and some breathing space. You have to make some decision here. I still have no idea where you are. So if you want, discuss with me. Let's decide some 2 topics, right? Shall we do that? I'm seeing energy.
And worksheet if you want to go through together.
Sure. Right. This is me getting to know you, right? Okay. Where does this come? Oh, this is just simple harmonic, right? Whatever we do, it'll be difficult, right? So we're gonna do this lah. Okay. So the MCQ is no joke lah, right? But they tell you something very nice. For a body undergoing SHM, the defining equation is that. Actually, I told you that also. What the heck does the negative sign means lah? If you understand, just tell me the answer. Oh, right. If I close ABCD, do you know the answer or not? I guess that's a better way of saying it. If I close the option ABCD, do you know the answer or not?
Oh wait, I haven't started the question yet. Let me just read it.
Right. Okay. Then close ABCD or don't read it. Just tell me the answer if you know.
Negative sign. A is acceleration. Omega is this is the name for omega.
Let's say I don't want
Something
definitions.
acceleration.
I don't want formality. I want what you understand. What's omega according to you?
Angular velocity.
Do you understand what that means? Kind of.
It's just how fast it moves like,
in a
this
circle.
way.
Okay,
Yeah.
let's say that's true. Okay, fine. Then
because if it's squared, then it'll always be positive, right? Then times
that's
x.
true. That's true, right? That is all. That's true. Yeah.
So then negative would mean that it's like inversely related. So if A increases, then this times this will decrease. Or if this increases, the acceleration will decrease.
I will inform you that is actually, I think that is considered wrong, right? Now let me give you a hint to think about it, right? Don't look at ABCD, please. In fact, just close it. Just close it. Just close it in a paper, right? So that your brain doesn't very thoroughly see it. I really mean just close it. Easier for you. Okay, good. Let me give you a hint, and then we'll talk about. Hopefully, it'll explain why I say no, right? A is acceleration. You know, X is
X.
is
amplitude.
Right. So X is not amplitude. No. Wrong.
Okay.
Try again. Okay.
Time?
No, definitely not. Time they will use T1. Especially in physics, they will not use anything else, definitely. And X is reserved for somebody very specific. So X is also not random here. They actually standardize it. So what does X mean? It's not amplitude. No way. Let me give you an analogy. Give an analogy. Give an analogy. Small t is time, right? Small t.
Yeah,
right?
Yeah.
Big T is what?
Period.
Correct. So big T and small t, they are related. I mean, period is about time, but period is not exactly time. Is that confusing or is that okay?
Yeah, I get what you mean.
So the analogy extends to amplitude, usually big A, usually, and small x. What is small x? It is similar to period and time. It is amplitude and what? Uh-oh.
So no, intensity.
No. Oh, I think you're referring to waves. You see me, right? You see me, right?
Yeah.
Okay. So look at time. Yeah, I'm doing a circular motion here. Right? Now time can be this, right? A little circle. Time can be that, right? Or time can be that, right? But period is always like this. That's one period, correct?
Yeah.
If you have this amount of time, can you estimate the period? Just saying.
No.
You can. If you know how many circles it is. So say this is 1/6 of circle. If they tell you, they tell you the angle. Oh, this is the time taken for 1/6 of the circle. Then you know what the period is. Makes sense?
Yeah.
So this is your big T, one full one. And time is, well, however you want to count. It can be small t like this. It can be small t like that. That's why they say small t is variable, and period is usually not. Right? It does vary in certain cases. So far so good, yeah? Now, amplitude. I want you to imagine a wave, right? So a wave looks like this, right? Okay?
Yeah.
Tell me what's an amplitude, right? Tell me what's amplitude. I'm going to move my finger, right?
Yeah, that's amplitude.
There you go.
Try
again. Point. Is it this one or is it this one? Just saying.
The maximum point.
Good. So here, I have an amplitude, right? have amplitude.
Yeah.
What is this? What is that?
Amplitude times 2.
Right. This is amplitude times 2. I agree. Like here, this is amplitude times 2. This is not amplitude times 2. Look. This is not yet 1 amplitude. This is almost 1 amplitude. This is more than 1 amplitude. This is, well, 0 back to 0. This is almost 2 amplitude. I'm still doing this. How can you say that this is 2 amplitude? Not correct. What is this? Come on. What is this?
So it's a period of a wave.
Because amplitude is meter, shift your brain from time if you can. Okay. I know this happens in time, but this don't just involve time. This is also what? Amplitude is not time one. The unit of amplitude is?
The frequency.
Frequency is related to time. Come on. What is this? Amplitude, the unit is? It's not second, right? Yeah. Yes. So meter is not a unit for time. Meter is a unit for, come on. Meter is a unit for, a very normal unit for?
Distance.
Correct. Distance is almost correct. This.
Oh, displacement.
Yes. Thank you very much.
Okay.
Makes sense, right? Your brain is just focusing on one. What happens in wave is there's always displacement and there's always time. That's why the graph is displacement over time. Both happens. Your brain must see that way. Cannot just see one or the other. Must see both. Yeah. So your brain now adjusts already lah. So this is of course time and of course displacement. Therefore, displacement has its amplitude and time has its period. And the brain makes sense now.
Okay.
We are no longer talking about definition. Who cares, right? You can memorize that yourself. You don't come to tuition for definition. At least that's not what I think. Can you? Now back to the question. I'm adjusting your brain for the question now. A is acceleration. You have problem with x. What is x?
Displacement.
Now, question mark. Now I ask you something. Adjusting your brain. Distance and displacement. Why do you say, oh, displacement? But when you say distance, you're not very sure. What's going on here?
Not very sure.
All right. Think carefully, yeah? Think carefully.
All right.
Amplitude, right? Okay.
Yeah.
This is distance is normal people usage. Normal people will think in distance, but when you talk about physics, you are forced to think about displacement, right? So distance, let's say this is, let's say this is 1 meter. Very simple, right? The amplitude is 1 meter, right? 1 meter.
Yeah.
The distance I move?
2 meters.
Yeah.
Up and down.
The displacement I move?
0.
Good. Clear, right? So one more time.
Yeah.
0. Then the displacement I move?
1. -1.
Good. So you know what minus means. -1. The distance I move?
Total distance will be 3 meters.
Yeah. Normal people never say I move -1 meter. They look at you, they think you're bonker. Something like that. They never think like that. What? Nor there's a usual need to do that lah. But in physics, we need to. Now, x, distance or displacement. You're gonna, if you don't know, you're gonna make a guess, an educated guess. Guess, Daniel, what is x in this equation?
Displacement.
Question mark. That's an educated guess. Let's see whether you're right or wrong. Now, what is the meaning of minus and plus if that is a displacement? What does it mean?
I think there's a minus because it's not only displacement, there's also the omega squared, right?
No, as you say, the omega square will forever be plus. even though angular speed or angular velocity, it is correct lah. Omega is supposed to be angular velocity. Obviously, circular motion has a direction, what, either clockwise or counterclockwise. Obviously, right? That's obvious. However, one is positive and one is negative, right? That's the fair way of describing them. So far, so good?
Yeah.
So far, so good. When you square them, the information is lost. Omega square no longer can tell you, is it a circular, is it a counterclockwise or is it clockwise? The direction information is lost when you square them. Let's just say that for now. Let's just pretend that that's true for now.
Yeah.
So I want you to direct your attention only on acceleration minus nx. Acceleration minus nx. If x is displacement, what does the negative mean?
Negative displacement.
Negative of the distance. Look at. Do you realize that we just automatically define upward as positive, right? Upward, right? Upward as positive and then downward as negative. That's the usual way people do it, right? For your information, there is nothing that stops you from defining bottom as positive as long as the top is negative and you're consistent. Just saying that. Okay, there's nothing wrong with it. So positive displacement, still positive, then 0, and then negative displacement, right? Negative 1 meter. Again, one more time. Positive means what and negative means what? It's a very simple thing. You're probably overcomplicating it. Positive means what and negative means what? No. Try again. This is our normal brain refusing to acknowledge negative, really. Normally, we don't talk about negative distance one, negative displacement. We don't understand. I'm adjusting your brain, okay? Not that you're crazy, but so that you kind of pay attention to the physics things. Now, force, okay? I'll just talk about force, easier. Hiya, okay? That's a positive force, okay? That's positive 100 Newton. It hurts a lot, so I cannot do now. Positive 100 Newton. What does negative 100 Newton mean?
Force in the opposite direction.
Very good. That's it. Force, you understand. Positive 100, negative 100. Simple, right? Positive 100. So, negative 100.
Other way.
What does positive displacement means and what does negative displacement means?
Up and down.
Or left and right?
Left and right.
You use a very fancy and correct word when describing force. Your brain accepts force. It's the opposite direction. You cannot say that positive displacement means up. Cannot say that. Negative means down. Cannot say that because some question will define negative as positive, downward as positive, and therefore upward is negative. They can do that one. It's not their fault. They're not playing with you. But in force, you use a fancy word, the opposite. Very good of you. So what does negative displacement means? The opposite of whatever the positive is. Is that a lot of words?
Yeah.
But in force, you understand. Okay, look.
I get it.
Here's a positive force. So here's a negative force. Simple one. The opposite lah. Here's a positive force. So here's a negative force. Simple, right? So x, small x is displacement. Negative x simply means the acceleration is
opposite direction.
See. Now your brain is just because x can be upward or downward one. So when x is upward, negative x is downward. When x is downward, negative x is
upward.
Yeah.
That's crazy.
Oh, they assume that you understand that, the moment they give you A equals to negative omega squared x, they assume that you understand. That's how I guess that's why you come to tuition, to understand the important things. It seems important, at least to me. Now, would you like to write some notes first here, exactly on this thing? You can transfer it elsewhere later. Write a very quick note, and then you see the MCQ, and then you answer. Don't see the MCQ right now, okay? I am paying attention to how you write notes. I hope you write notes for yourself, not for the teacher, but for yourself to understand your future self. Let's see whether you do that. I'm going to turn off my video. Okay, much better. Right. I'm going to interrupt your train of thought just for a while. Sorry, yeah. Your future self will like this note or not? Just check very quickly first. Will your future self like this note?
Yeah.
Okay, good. Please continue. Sorry about that. Okay. All right. I assume that you're ready with your note, yeah? All right. So answer. Oh, well, you are correct. Correct. I almost didn't expect you to answer that fast. Right. Any questions?
No.
Right. Okay. If they have no question, let's continue.
All right.
All right.
Yeah, the period is double to 20 seconds without changing the oscillation. Develop. Is it 250?
Now, I guess I will feel more comfortable if you show some calculation. I'll feel more comfortable.
Okay. So period is like that. So it's split into 4 parts: up, down, down, up. Then divided by 4. And if it has a period of 10 seconds, it has a period which is double to 20 seconds.
Okay.
Without changing on the amplitude. That.
Okay.
Right. It has to go all the way down. No.
Yeah, correct. Something like that. You're drawing something that I can follow. Yeah.
Yeah.
Might I ask you to use pencil? I think slightly better, right? So that you don't have to. Treat this as your note.
All right. It just came to me like it's instinctual that it's divided by 4. I'm trying to think through how I thought that out.
Yeah, you need to lah, because there's no point in me saying it is correct or it is not correct. Really, there is no point.
It's 10 seconds.
Nice.
This is time.
Mm-hmm.
So you have like that. This is the second one. This is the double without changing the amplitude. So your energy from 1000 to 20, if your amplitude was changed to 1000 to 20, and it would be just 1000 divided by 2. Because the would do like that, right? If I'm not wrong.
Yeah. But your amplitude does
Right.
not change, right? Yeah, your amplitude does not change.
So, but since the amplitude does not change, you divide it by another 2, because this is double of this. So if 500 divided by 2, it's 250.
I'm not sure, but this is how you think of it, correct? Yeah, you just explain how you think of it, correct?
I think so.
All right. So at least you understand yourself. That's important. Yeah. Now, I'm going to give you another point of view. So see whether that makes sense or not. Remember, I'm not trying to lecture you. Yeah. That's not what you want. That's not what you need, I think. Right? Okay. So, simple harmonic motion is a very fancy word. Okay. It's a very fancy word, right? It is very appropriate, but that's not what normal people will understand. Yo, bro, you just did a SHM, right? Yeah, people don't understand that, right? Okay, now, what do you understand about simple harmonic motion?
It just oscillates about a point.
I like the word oscillate. Can you use an even more normal word if you have?
It goes up and down.
Or left and right, by the way. By the way,
yeah.
or also, so just saying, right? It goes one way and then the other way. Let me just clarify. It goes one way and then the other way and then one way again, then the other way, back and forth, back and forth. If there is no damping, is damping okay? Can I mention damping?
Yeah, sure.
If there is no damping, what will happen to the back and forth?
It goes on forever.
Right. Obviously, practically that does not happen, but you get what I mean, right? I get what you mean. Yeah. Now, I'm owning my video. By that, you can tell immediately whether something is back and forth or not. Back and forth is something that normal people understand, right? So here is the thing, it's a nail clipper, who cares, right? Is this back and forth?
No.
But I say to you, it goes up and then down. That's back and forth one.
It's to return to its original position.
So back and forth. Is this back and forth or not? You just say it.
It is back and forth, but it's not simple harmonic motion.
Why is it so, according to you?
Because it has to travel both ways. So if it goes up, it has to go down also.
See, up and down.
Like, let's say your hand is a starting point. Okay. If it goes above your starting point, it has to go below the starting point in equal distance.
Oh. You're getting more detail, and obviously you're correct. If I do that, so it will just drop off and never come back, right? You cannot even see.
So it has to come back after it goes down.
Right. So you have to do this, right? Okay.
Yeah.
Okay. Visually easy to understand, and I totally agree with you. Nothing wrong with that. Now, here is what I want to tell you. When this goes up and then it goes down, to keep it simple, it does not have the ability to store or convert its energy. One more time. If you want this to go back and forth, he has to somehow store the energy so that it can come back and then store the energy again, and then it has to come back again. I'm not sure whether this makes sense for you. I have to go from kinetic energy to storing my kinetic energy, to kinetic energy again, to storing my kinetic energy, to kinetic energy, to storing my kinetic energy. Then I will have a forever movement. If not, I will have a very one-directional movement, and then that's it. So far, so good? Right. So when I say stored energy, what do you understand?
Probably elastic, right?
Can it be another form?
Gravitational?
Yeah. Elastic, potential energy.
Swinging.
Yeah, swinging. This is considered SHM because it is going back and forth. When I swing here, I have kinetic energy, and then when I swing upward, I'm storing as potential, releasing kinetic, storing, releasing, storing, releasing, right? So far, so good. You have to have a way to store it. So that's why you have to deal with potential energy, either gravity or elastic. That is the third potential energy, chemical, and physics do not like to deal with chemical potential energy. So lucky, we always have to deal with two. So elastic plus kinetic or gravitational plus kinetic. Any way to store it and release it as kinetic, right? So far, so good, yeah? This is not too difficult. Now, what is the phrase total energy mean to you? What does that mean to you?
Total kinetic energy.
So the phrase total energy to you means total kinetic energy. Am I correct?
Total energy would mean like, because there are many different types of energy in a system.
Yeah.
So you can have like
so in
kinetic,
SHM
gravitational,
system,
all at the same time.
All right. So let's make it
SHM would involve everything.
No, not necessarily. Like, for example, the pendulum only involves two, gravitational and kinetic symbol.
But
it doesn't have that. They don't want to talk about heat as a storage. They really don't want that. They don't want to talk about sound. Definitely not, because those are damping. You're talking about damping already. You're talking about the loss of energy from the system. Fancy word for damping. That's why damping happens. So no damping. No air, no sound, no heat for now. That is not what total energy means anyway to them. To us, why are you excluding sound and heat? You racist. Yeah, but for some reason, they exclude that out of the definition of total energy. You have to be on the same page. What does total energy means to them? Unfortunately, Daniel, are you okay? Sorry, Daniel.
Yeah.
Can you hear me, Daniel? Sorry.
Yeah.
Oh, okay. Do you have any idea what they mean with total energy?
Is my video paused?
It seems okay. Okay. So what does it mean? What do they mean with total energy?
The total amount of energy in a system.
Yeah, what energy is involved? Turns out it's not everything. Turns out.
Kinetic, gravitational.
All right, let's call kinetic and gravitational for a pendulum. So let's pretend that we talk about pendulum here, right? Let's pretend this particle undergoing SHM is doing a pendulum motion, even though particles don't do that at all. Who cares? Whatever. This particle is doing kinetic, gravitational, kinetic, gravitational. The amplitude, well, tell me this pendulum. I'm going to make a bigger pendulum, okay? The pendulum goes like this. Tell me where's the amplitude of this pendulum? The amplitude is what?
At the top. The maximum, at the point where it turns around.
Like that. Like that. Yeah, the height you mean. Height you mean.
The highest point.
Okay, the highest point and the lowest point. Is that what you're saying?
Just the highest. Right.
How can the amplitude be only the highest point? That doesn't make sense.
Wait, thinking. It's more like left to right. Like if your resting point is the middle.
Okay. Right? So this is the amplitude.
This is the amplitude. Yeah, the two furthest points will be amplitude.
Okay. So let's say that this is the amplitude. Okay, I'll just follow you. So let's just say amplitude, right? So do you notice that here? Actually, you're wrong. Actually, it is the middle point and the extreme point. It's not the two extreme points. Amplitude is always, like that. If I'm doing this, then the amplitude is this low. There's a mean point. That means there's a, there's the starting point. There's a mean point. There's a middle point. So amplitude is not this, but half of it. Are you okay? It's only half. The pendulum goes from left to right. The pendulum goes from left to right. The amplitude is only half of that line. Are you okay now?
Why would it only be?
Okay, when they do up and down, you never protest that. You call up and down. Okay, if I go from up to down, that's two amplitude. That's what you said just now.
Yeah.
So how come when I'm doing from left to right, you call the left and right full one amplitude? Wait, why the double standard? It feels like double standard to me.
That's hard to explain.
Are you sticking to your position?
Stretching my legs.
Okay.
A bit sore.
Right. No. I don't mean your physical position. I mean your mental position.
Oh. Okay. Why would it be half only?
Okay. When I move up and down, why would the amplitude be half of that up and down? Why would it be? What's your definition? What's your thinking here?
Come. I visualize by drawing.
Oh, yes, please. And you can draw in the Jamboard, and I should. Are you using the untitled one?
Yeah.
Okay. I'll follow.
How do you insert a new page?
Click the square. No, click the square. Yeah. No, the square. Let me teach you something. So click the square instead of the arrow. The square, please. The square in the middle. Yeah. Then you can also insert papers in between if you wish to. It'll be useful.
Okay.
Right. So I'm following you at page 7, right? Okay, you do you.
So let's see your point. And wait, this big ball is your pendulum. And it swings.
There,
it swings like exaggerate a bit.
Yeah, that's fine.
It swings like this much.
Yeah. So from there to there to there, right? Okay.
Here.
Yeah, and then go back.
So if you look at it like just in terms of the height.
Just in terms of the height.
Oh, I see what you mean. So the middle point, this point over here would be like the amplitude has to go up and down a set point, right? Okay, so this will be the highest. This will be the lowest.
Okay. Sorry. I'm sorry to burst your balloon. Sorry. No, I'm sorry to burst your balloon. This is going to be weird. Yeah? I'm going to say something that feels weird for a while. So you take it in. The way you define it is the vertical position, right? Because pendulum does seem to go up and down. In addition to left and right.
Yeah.
In addition to left and right. Now, bursting your balloon. Now I'm bursting your balloon. You cannot define pendulum as up and down. You must define it as left and right in this situation.
This is the resting point.
You can say that that's the mean point, right? It's not really resting there. So let's say mean, maybe better mean, right? Or zero displacement. Maybe we can say it that way. Zero displacement. Right? Maybe that's a better way. And so you will suddenly have to define what is positive and negative. For the sake of brain, let's define left as positive so that your brain get used to it. Because you're allowed to do that, so to speak. So you have, no. Define the one to the left as positive so that your brain get used to it. So the right is automatically. Right. So where's the amplitude?
Left and right.
No amplitude. Like show me where's the amplitude. Okay. Now if you bring no, what's the amplitude? Where's the amplitude?
Amplitude. Assume to the positive.
Okay. Now, if you don't mind this, if you feel that this is correct, okay, don't use small a. Small a is for acceleration. You cannot use small a. No. The most you can do is big A. However, big A is also very bad. What you can use is X max. X max. Would that be okay? X max.
Sure.
So maximum displacement, no matter positive or negative.
All right.
Now, does your brain reject if I say this is also X max? Will you be able to accept it?
I guess, yeah. I mean, like negative X max.
I guess that's also fine for now, right?
Will they make
I don't
it
mind
X min?
No. Surprisingly, X min is 0, not -3. They don't like to say that -3 is minimum, nor do our brain actually accept that. I don't think that should be considered minimum, because minimum carries a different connotation. It should be on the 0. I think that's more appropriate. And they never define -3 as minimum, also never one. So they're consistent that way. I think they want easy to accept. Okay. Right. So far so good, yeah. Kenya. All this amplitude discussion, right? So why are we discussing this, right? So at X max, what kind of energy you have? I'm going to use a different phrase: stored energy, or release energy, or a mixture of both.
Both.
No, at X max, your speed is 0 for a while. So your kinetic energy.
So because can you see like the turning point?
Sure, no problem.
Okay. So the turning point, it only has gravitational potential energy.
Stored energy, because it can be elastic also. Stored energy, because there is no speed, so fully stored. At minus X max.
Minus X max.
Energy wise,
the same.
Fully stored.
Exactly the same.
Good. Fully stored, and then anywhere in the middle there will be release lah. So some sort, some release, right? So far so good, yeah. Now directly in the middle, 0 displacement, you have minimum gravitational potential energy, minimum stored energy. You can define that minimum as 0. Even though this is above ground, it's okay. You can define that as 0 gravitational energy, therefore 0 stored energy. So far so good. Which means at 0 displacement, the lowest part, you have full release energy, fully released. And fully stored, fully released, a mixture. Fully stored, fully released, mixture, fully released. Mixture, fully stored. Can?
Yeah.
Now, here is the question that will show you whether you're right or wrong. The total energy here at fully stored, is it the same as the total energy at fully released?
Could you repeat that again? Sorry. I'm just trying to...
I'll break it down. What is the total energy at the fully stored point? Let's pretend that
will be the total energy in the system, because energy is not, it cannot be gained or lost. It cannot be destroyed. So
no. Forget that. Just forget it. It can only be changed. I know, but let's forget that for a while. That tends to mislead people. So let's pretend that at fully stored one, we have 1,000 joule, right? 1,000 joule. So what's the total energy there? See, you hesitate. That's why I asked you to forget about that definition. I have 1,000 joule gravitational or stored energy at the maximum here at this 2 point. What's my stored energy there? No. What's my total energy there? Good.
1,000.
Correct. Now, at the fully released position, I have how many kinetic energy?
1,000.
Therefore, my total energy is
1,000.
Now, in the middle between fully stored and fully released is a mixture. What's my gravitational potential energy? In between lah. What's my kinetic energy? In between lah. What's my total energy?
Total will be 1,000.
Good. Total energy 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. Always 1,000.
Yeah.
At the maximum, your money in the bank is $1,000. If the money in your wallet is $0. You know what happened to money in wallet, right? Money in wallet tends to disappear. Money in the bank tends to stay, right? So stored money disappears slower, right? You have to go through a process, but they make it easier now with Pay Now and PayWave, to make the money in the bank disappear fast. Right? Let's pretend that we don't have credit card and PayWave and whatever not. So the money stored is 1,000. The money in the wallet is 1,000. So this is maybe stored 700, wallet 300, something like that. The point is your total money is 1,000 all the time if you don't spend. Only a crazy person will take money from bank, put to wallet, put it back to bank, put it to wallet, put it back to bank, put it to wallet. That's a crazy person. But the point is your total money is 1,000 if you're a crazy person. Okay? And yeah. Now back to the question. Let's see whether you see your mistake or not.
Okay. Oh, this is 1,000.
As weird as that conclusion is, look at my hand. I'm 1,000 here, right? I move very fast from here to here. My total energy 1,000 watt. If I move slower, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000 also what? Because it depends on the amplitude. It depends on the height, not how fast or how slow I move. It's 1,000, 1,000, 1,000 fast or 1,000, 1,000. You get my point.
Yeah.
It's very counterintuitive for SHM. That means your question is no joke. That's what I feel. Would you like to write some notes?
Yes.
Yep. Oh, when you're done, tell me. I cannot tell them. No rush. You look at your note for first question and second question. Will future you, let's say the exam will be when? Second week? Let's say that. Is it second week?
I really don't know.
Okay, let's pretend it's the second week. So you enter your school next Monday, right? We tell you the syllabus for the exam. You will now rely on your note. Will future you like this note? Just checking.
Yeah, I think so.
Will one day before exam, future you thank you for this note?
I doubt future me will find this one worksheet the day before the exam.
Which is a problem of organization, not a problem of note taking. Let's pretend that you don't have organization problem. I notice that you have, I do notice that, but not as bad as my other student. Let's pretend that you are a very organized person. Will future you see this note and be grateful?
Yes, so.
Right. You sure? Yeah? Right. Now, let's solve the organization problem. You're saying that you cannot keep this for future you even 2 weeks from now. That's what you're saying, like basically, based on your experience.
Oh, you mean in 2 weeks? Yeah, 2 weeks I can. I'm talking about like IB exams.
Yeah. Okay, 2 weeks first. 2 weeks first is fine. 2 weeks.
Threes can.
No problem. Okay.
Yeah, no
After
problem.
exam, then we organize. Then we don't have to talk about organizing now. We'll just talk about it after exam when you free your mind of the past topic. And therefore, everything else goes out of the window, something like that. That's when you lose your notes. That's when you lose, and that's when that's the latest we must organize. Though don't have to be now.
Okay.
So let's talk about it now. Formally, you're not an adult. Can I consider you an adult? Is it possible? Is it okay for me to do that?
What do you mean?
If you're an adult, then I can take a certain risk with you. If you're not an adult, then I cannot.
What risk?
All right. I want to try taking a risk of you hating me a bit.
Okay.
Right. This is the why lah. This is right. So, that's me. If I be rigid lah, then I'll say something like this. Okay, 7:30 to 9. 9 you're supposed to stop. Even though this is only 1 hour, I consider this already an hour lah. Right.
I don't mind going all the way to 9:30 if that's what you're asking.
No, that's not what I'm asking. I'm asking you to consider this 1.5 hour done already. Because 7:30 to 9.
I mean, sure. But if you would like to go on, I'm also down to go on. That's all I have to say.
Now, let's be clear of what I mean, right? If we consider this 1.5 hour done, not just 1 hour, right? 1.5 hour done, then I'm hoping that future you will not be late.
Okay.
Right.
That's a fair assumption.
It's fair, but that's why it depends on whether you are or you are not. Now, which one do you want?
I'm really fine with anything.
Then I'll make the... Are you sure?
Yeah, sure.
Then I decide to risk it. Okay?
Okay.
Right. Now, for tomorrow, right? For tomorrow, shall we continue talking about, this is a recent past, this is a recent past for preparation of exam. Is this a good idea? No?
What do you mean by that?
Because it'll affect my homework for tomorrow. If you're not talking about gravity field and electric field because you think this is a better idea for now, then my homework is to ask you to simply do this paper, this thing, right? Because it's very likely to come out in exam, right? Something like that.
Yeah, quite likely.
Right. So it makes sense?
I've already done the homework. I can upload it into the Jamboard. You can take a look at it whenever you want. First,
you can. You're talking about homework from other topics, correct?
Yeah, from the gravitation. I've done the homework already. There are some questions.
I'm sorry. The gravitational field, they have homework for you.
You gave me homework.
Oh no. That's what I'm saying. Of course, we can talk about that, but it's very unlikely to be in the exam. Very unlikely. So I want to talk about it when you feel ready or you feel enough for exam preparation. If not, then we are clashing our interests. Are we talking about gravitational field, but we are neglecting your exam? It's not a very nice feeling to have the nearer it is to exam. It's not nice, right? So we forget about that for a while. Keep it, don't lose it. That's an organization problem. You tell me if you have a problem, right? And then focus on this topic, for example, for tomorrow.
Okay, sure.
Makes sense, yeah? Now, do as much as you can. Of course, I would like it that you try everything, but that will depend on how much time you want to spend. Right?
Yeah.
Okay. So I take it for tomorrow, it is a good idea to talk about this piece of paper. Okay.
Okay.
All right. I'll see you tomorrow then.
All right. Bye
Don't
bye.
hate me too much, okay? Just a little bit.
Okay.
All right. See you.